Greg Lamp is the CTO of Yhat, a data science technology and operations company. Greg, welcome to Software Engineering Daily.
Hey, Jeff. Thanks for having me.
At a software company, what is the typical relationship between data scientists and software engineers?
Well, with the companies that we're typically working with, we find that data scientists are on sort of one team where it's much more, as you might imagine, looking at data, answering business problems or questions that management or the company might have using that data. And then on a separate team, you have the software engineering group, where that's where your really application development is done, whether that's a website or a mobile app or back-end ETL work, that kind of stuff.
What are the points of an application that both the data scientists and the engineers are touching?
Well, what we found, and this is one of the reasons why I started Yhat a couple of years ago, is that where both engineers and data scientists are working on the same piece of their application is usually something like a real-time prediction or a recommendation. So an example might be on Amazon.com, they have if you liked or looked at this pair of blue jeans, you might also like this pair of tennis shoes. And so that's an example of a component of a web application that has a data science component to it as well. And so you have to have both engineering and data science teams working together in order for that to be a successful feature.
Is there a typical workflow between the data scientists and the software engineers? Like, are the data scientists communicating the spec that they need from the software engineers or vice versa?
Yeah, so the way that I found it typically goes is that a data science team will come up with a new algorithm or new recommendation engine, something that they want to try out on a company's website. And once that analytical work is done, usually what happens is data scientist just kind of throws that work over the wall to the engineering team and just sort of says, hey, here's this, whatever it is, random forest model that's predicting what pair of pants this user might like. Can you put this on the website? And that's just kind of the end of it.
Yeah, we did a week of shows about DevOps, and one of the recurring themes was there was this idea of a wall of confusion between dev and ops, and the DevOps movement is about eliminating that barrier of confusion. Do you feel that there's a similar barrier of confusion between data science and engineering teams?
Yeah, absolutely. What I've noticed, and one of the core problems that we solve at Yhat is that you have teams of data scientists who they're writing code, they're doing analytical work, use things like R or scientific Python, Pandas, MATLAB, tools like that. You have your engineering team who are using things like Ruby on Rails or Node.js or pick your favorite web technology. And even though you have these two groups that are both very technical, very capable, they're both writing code, but it's really hard to take that analytical code and get it to work with sort of your production code or the code that's actually being used to build your company's applications. And so there's just this huge disconnect between the two parties.
So assuming that these companies are not using Yhat, what are the ways that data scientists and software engineers translate code between these two types of platforms?
Yeah, so this was actually one of my first jobs. I was the guy who had to figure out how to do this. And the most common way is that there'll be one person who takes these, call it a model written in R, and they will go line by line through that data scientist's work and translate by hand that code into the production stack for a given company. So at my previous job, I was taking R code and going line by line and translating all of that into Java. And it's really tedious, super error prone, and what I found is that I spent a lot of time just going through and finding tiny bugs or just validating that what I had was the same as what the data science team was trying to implement.
Yeah, so I actually had that same job at a ad tech company where I had to translate some data science stuff from Python to Java, and it was just a nightmare. I saw a YouTube video where you were talking about how you had to translate, like, I guess it was a 120-page PDF of code from one language to another.
Yeah, that was
and that
rough.
sounded really familiar to me.
Yeah, that was rough. But yeah, I mean, at times it's data science can be fairly academic to the point where you're really just taking a paper or a spec for something and going through and trying to make it useful in the real world, and it's very time consuming, or it can be.
So we've outlined some of these problems that the data science and engineering teams have when trying to work together. What does Yhat do?
Sure. So Yhat helps companies take their data science work or analysis and embed it into other applications that company is using. So, great example, one of our customers is a bank in Europe, and for each one of their branches or their online presences in different countries, they have different credit models that they need to run on those individual websites. And so they use Yhat to take, for instance, the credit model that runs in the United Kingdom, and they take that R code, send it to Yhat, and then they can use the output of that and embed it into their site so that when you have people come into that site, they're making predictions in real time using their latest models.
So would you say that Yhat sort of turns data scientists into like restful endpoints?
Yeah, that's definitely one way to put it. The REST API
so it sort of turns your data scientists into a service-oriented architecture.
Yeah, what Yhat makes it really easy to take something that a data scientist has been prototyping and working on and immediately deploy it and turn it into an API that's instantly consumable by anyone else at the company.
Interesting. So how to delve deeper into that, how does Yhat reduce code translation?
Sure. So the biggest thing that we do is that we actually run the exact code that data scientists are developing in a production environment. And so what that means is we're running the same scientific libraries, we're running the same helper functions, the same data artifacts that they have on their laptop. We have a process that automatically translates that into a production-grade web app that exposes an API, which software engineers at that data scientist company can use to access the models and the data scientist's work.
What does the engineer need to know about, so like if a data scientist writes some query and exposes it as an API endpoint, what does the engineering side need to know about the black box that is doing that work, that running that query and updating the result of that endpoint?
Really, all the engineer needs to know is the data that is fed into the model, or the data that model needs in order to execute a prediction. So that could be something like a user ID for a given customer. That could be data points that have been collected at different phases of a e-commerce checkout site, or that could be calls to a third-party data source like a credit bureau in the case of a financial services company.
Okay. What's going on behind the scenes? Like, what technologies did you use to construct this system of creating RESTful endpoints? Did you abstract it, or did you build it on top of any sort of like Node.js libraries or Rails libraries or anything?
Yeah. So the biggest technology we sort of selected early on Docker as a technology that we could leverage as a way to isolate and run these models as APIs. And what Docker allows us to do is provide a safe environment for one of these APIs to execute where it's independent of other models that might be running at the same time. So instead of just having one API endpoint per server, we can have 10 or 20 or we've had as many as 60 data scientist models running all from within the same hardware configuration.
So we've done some shows that talk about Docker, but just for listeners who aren't familiar with it, could you talk about why Docker is so important and I guess what Docker does?
Sure. So the Docker is really, I think it's a pretty simple concept. Docker takes the idea of a VM or a virtual machine and allows you to split a VM into sort of little separate mini VMs. So you can think of it as like taking a server and splitting it up into n number of little mini servers that are running. And each little mini server has their own operating system, has their own isolated environment, and allows you to do some pretty nifty things like control the data input and output from each one of these containers, isolate different packages that you want to run or different files that need to exist in one container but not the other. And so it really makes, for us, it makes running individual APIs on a single server a lot easier.
So let's get back to talking about Yhat's technologies. One of your products is Science Cluster. What is Science Cluster?
Science Cluster is a workbench for data scientists to leverage cloud computing resources like Amazon, for instance, without having to go through some of the IT headaches of spinning up an AWS server, installing the packages they want, managing different sort of scripts or threads of execution that they have going on at the same time, and it lets them do it easily without getting the systems administrators or IT department involved.
Is Science Cluster an operating system?
No, I wouldn't call it an operating system. It's more of just a web application that kind of controls different jobs, scripts, IDEs, things that are running on a server that are specific to doing data science.
How does a user deploy Science Cluster?
Sure. So all of our software, we ship our software via Linux packages. So we have deb files for Ubuntu, we have RPMs for Red Hat and CentOS. So installing it is really just a single command, either apt-get install Science Cluster, and the script kind of bootstraps itself and gets you up and running.
So I guess I'm still not clear. Does a user deploy Science Cluster to his own machine, or is it hosted on the cloud, or are there no requirements? You can do whatever you want.
There's really no requirements. So that was actually one of the things that we found kind of early in starting Yhat, was that our customer base was very sensitive about their data. So, I mean, you can imagine privacy, not being able to send their data to a cloud or a hosted service. And so all of our software is designed to run either on-premise or in our customer's Amazon account or other VPC.
So this is kind of an aside, but I've heard these kinds of concerns about security when using a managed cloud service, but haven't we gotten, like, as a engineering society, haven't we gotten beyond the point where we like collectively acknowledge that it's more secure to have your stuff in a cloud hosted environment than like your own environment?
Yeah, I would say, I personally definitely have, but for us, it's more of our customers, and
Sure.
our customers kind of, they run the gamut in size and industry, but a lot of them are larger publicly traded companies, and who really just haven't bought into the AWS, cloud hosted services quite yet.
It's the kind of thing that makes you realize how much of a bubble we live in sometimes.
Yeah, it's like that sort of the Hacker News bubble. Yeah, my thought on it is, like, Amazon knows a lot more about security than I do, so I tend to let them handle as much of it as possible.
Yeah. So do you need a DevOps person to set this up, or is this something like an engineer can just sit down and say, I know I need Science Cluster, I can go to figure this out very easily?
Yeah, it's super, super easy to set up. It really just depends upon the company that we're working with, but probably 50% of the time we're working directly with the data scientist for an installation. 50% of the time we'll work with the company's IT department, and then this again kind of goes back to the whole security, cloud hosted versus on-premise thing. But installing our software is, like I said, it's about 1 or 2 commands, and then get you up and running in usually under 30 minutes. So it's pretty simple.
And how customizable is it?
So this is something that kind of goes back to Docker. One of the reasons why we selected as one of the technologies we wanted to use is Docker lets you mix and match what libraries or dependencies are installed from within the runtime environment. And so what this means for our customers is that we can include very specific libraries. We can include proprietary Python or R packages in our software's distribution that makes it really easy for them to kind of work the way that they want to work. They're not confined to a specific set of libraries. It's really anything that they want to install can be included in our product distribution.
So to talk more about the Science Cluster product itself, it's been popular with data science professors who are teaching classes. Why is Science Cluster useful for teaching a class of data science students?
I guess the Science Cluster just provides a way that you can have one professor who might have, I think the biggest class that we work with is about 180 students. So you can have one sort of main hub for all of the students' data science work to get done, and the professor can easily administrate and provide course material, kind of like we said earlier, install specific libraries or packages that students might need for a particular lecture or class. And then it also prevents students from having to set up their own data science environment, which we've found that can be really time-consuming and difficult for someone to do on their own. And then add to the fact that you've got a student who's probably new to scientific computing to begin with, and that just sort of magnifies the pain point.
Sure. So Yhat has another application called Science Ops. What is Science Ops?
Yeah, so Science Ops is our flagship product. Science Ops takes data scientists' analytical routines and allows them to instantly deploy them as RESTful APIs. And those APIs can be accessed by software engineers or other developers at their company with just a couple lines of code.
And so Science Ops lets a data scientist take analytical scripts that have been written in Python or R and turn them into APIs. Like you said, it's the flagship product. So I know we touched on this a bit earlier, but to reiterate, what is going on under the hood to enable those endpoints?
Sure. So each one of our customers' models runs within its own isolated environment. And that environment, using Docker, and that environment is set up using our software in such a way that it's going to include all of the dependencies, any sort of libraries that are required. That's something in scientific computing that tends to be somewhat difficult, is data scientist is experimenting with a new package, and they want to include it in a model, getting that into a production ready state, somewhat challenging. So taking that model, setting it up in a dedicated environment, mimicking mimicking the environment that they used to create that model, and then API-ifying or creating that API endpoint so that that model can be accessed by the outside world.
What's the user experience or the onboarding experience like for a data scientist who is familiar with, he's familiar with Python or R, but not necessarily with the Yhat workflow?
Yeah, so our philosophy is that we really don't think your deployment solution should impact your day-to-day workflow. And so Science Ops is designed to mimic a data scientist's existing workflow. So we have client libraries built out for Python and R. And in order to deploy code that you've written to Science Ops, you just import the Yhat library, define one or two functions for explaining how your code will run, and then it's just one line Yhat deploy, and that takes care of the rest in terms of creating the API and the environment and exposing it to the rest of your company.
So Science Ops allows a data science team to set up predictive models against API endpoints, and those models can be accessed by employees or customers or however the company wants to configure it. Can you give an example use case?
The best example is one of our first customers. They're a bank in Europe called Ferratum, and they use Yhat or Science Ops to take their credit models and run them on their public-facing website and inside of their mobile apps.
So the Yhat blog has a bunch of interesting posts about data science, and one of the recent posts was about how the blog itself is becoming really large and hard to navigate, and you decided to implement a search algorithm for the blog, and you realized that you could use Science Ops for this. How did you use Science Ops to build a blog search engine?
I was thinking about how we could, like you said, better organize our blog, and I had a really short Python script that I had written that allowed you to take just a sort of arbitrary input, search through the content of our blog, and then display the top 10 most relevant results. And so I took that Python script and I deployed it onto our instance of Science Ops that we run internally. And from there, I just rigged it up to our blog with a little bit of JavaScript and created a little input box where you could type in a search query, and that would hit the Science Ops API that I deployed and then retrieve results for the search engine.
Are there any really weird cases, use cases for Science Ops that you've seen your users implement that you would have never thought of?
Yeah, so originally we found that most of our customers were in financial services. It's sort of where my background was, and it has a lot of very natural use cases for science ops in terms of credit, lending, fraud, that sort of thing. But what we found after we started, had the company around for a year or two, is that there's a lot of interesting use cases, whether it's, e-commerce, doing things like recommendation engines. We've had text analytics companies, natural language processing, sort of everything. The weirdest thing I think that we've seen, there's one company who's using Science Apps for taking like input data from forms, so looking at the speed at which their users are typing, or whether they're using the tab key to fill out different forms, and using that data to predict their future behavior and to predict and segment those customers. So that was a pretty weird one that I never thought would be something Science Ops was used for.
Fascinating. So data science is the focus of this week on Software Engineering Daily, but the next theme that we're going to cover is Y-Combinator companies. And Yhat is a Y-Combinator company. So for those who don't know, Y-Combinator is a startup accelerator that invests in the early stages of tech companies. And we wanted to do a week covering it. And full disclosure, we want to inform the listeners that Software Engineering Daily is actually applying to Y-Combinator ourselves. So with that being said, what did you first have when you applied to Y-Combinator?
So we actually applied 2 times. The first time we applied was it must have been about 3 years ago, and we had a really poorly working prototype and just kind of hopes and dreams. And let's see, I remember we went out to California to interview, and the interview didn't go very well, and as a result, we were not accepted. But it did at least get us kind of working on the idea, and got myself and my co-founder Austin Ogilvy to quit our day jobs and dedicate ourselves full-time to Yhat.
Fascinating. So as I understand, when you actually got accepted to Y-Combinator, you had a pretty significantly working product. So when you actually got accepted, how robust was your product?
So we were accepted to the Winter 15 class, and at that point we had a functioning product. We had a few customers. The product had been in market for about a year, which in the enterprise software world makes a really big difference. And then we had actually already raised a seed round of funding. So we had employees, the company was already kind of off and going, and Y-Combinator was a great chance for us to, kind of go out to the West Coast and meet with some investors in California. And then going through the program obviously was quite an experience as well.
Were you hesitant to join Y-Combinator when you already had a developed company, a developed product?
No, this was something that we really wanted to do, and we actually had a few of our own angel investors had participated in Y-Combinator and were very encouraging and very pro in terms of having us go out there for YC.
Did Y-Combinator help you solve any engineering challenges, or was it mostly like product and fundraising challenges?
Not really on the engineering side, at least in terms of the technical details. They're extremely helpful on the fundraising and sort of navigating venture and angel investing. In terms of product, they were found that they were a great motivator in terms of, every week you go in, you meet with the partners, and you need to have some sort of improvement, whether it's improving for us, our blog and conversion funnel, or increasing the number of pilots that we had going on, or in the best case, the number of closed deals.
What was the most counterintuitive advice that you received at Y-Combinator?
That's a good one. I think some of the most counterintuitive advice was that Y Combinator really emphasizes sales and engaging and trying to reach as many of your customers as possible. So, for example, we were blanketing fintech companies with emails, trying to find those companies that were at that right moment where they needed one of our products. And you're on Hacker News, or you read all these blogs, you think that Y Combinator has all these like magical product and engineering recommendations. And the biggest thing that I got from them was just pushing sales and how important sales is to your company.
Interesting. So some of the tribal knowledge from Y Combinator, some of the tactics have become publicly available over the years through Hacker News or through Paul Graham's essays. And so with that in mind, what was it that you got out of the experience that you would not have been able to get just by reading?
Yeah, my favorite part was just meeting the other founders and the other companies that were going through Y Combinator with us. Our batch was pretty big. There were over 100 companies in the Winter 15 batch, and just being able to meet so many people who were so dedicated and so passionate about such specific problems or specific domains, I found to be made for some very interesting conversations and was a lot of fun.
Were there any Y Combinator companies who adopted the Yhat product?
No, unfortunately, I don't think any of them could really afford us. We're much more geared towards working with larger companies, on the order of 60 or 150 employees, as opposed to the 2 and 3 person operations in Y Combinator.
What is the cost structure for Yhat?
Sure. So we have enterprise software licensing. We license our software on a per server basis, and to be honest, the pricing depends a lot upon the customer. So that things like number of users, number of servers that they're going to need, that sort of thing. But it's all done on an annual agreement, and we provide support and updates, and obviously if they have feature requests or recommendations, we're also more than happy to include that as well.
What is the Moonshot goal for Yhat?
So the mega success for Yhat would be if we were sort of the data science company for kind of like enterprise software company for how data science gets done. So if you think about the sort of past 5 years, there have been sort of hype phases, you call them, in data. So there was Tableau that conquered the BI market, and then you had Cloudera, who conquered the big data. How do we process all the data that we're ingesting before we have to ingest more data? And I think the next phase is the prescriptive or the predictive analytics market. And so that's what we're going after. That's okay, we have all this data, we've made all these nice, pretty charts. How do we actually take that data and use it to forecast what's going to happen, as opposed to either processing the data we already have or reporting on historical data?
Yeah, I like the quote from Peter Thiel where he says, "Big data is often dumb data."
Yeah, that's very true.
So I read a quote from you that said, data science is the fastest growing undergraduate major. How does a data science education differ from a computer science education?
There's a lot of commonalities, but the biggest thing for, I would think, a data scientist would be focus a little bit more on the math side. So some more statistics, in-depth linear algebra courses. And then something that certain engineering programs do is like case studies or capstone projects where it's on the student to formulate not just solving a problem, but also figuring out what the right problem to solve is in the first place. And so that might involve some data collection, that might involve cleaning and scrubbing some data, and then finally synthesizing all of that into a solution or an answer that can be presented to some sort of stakeholder.
Is the role of data scientists becoming more distinct and different than a software engineer, or are data scientists and engineers becoming more similar, or how do you see that gradient changing?
I think they're getting more dissimilar. There's been kind of a rise in the idea of a data engineer, which historically kind of fell under data science, but kind of fell under software engineering. I think that's kind of helped set some dividing lines in terms of who's who. But I see data scientists as more of the people who are answering business questions, analyzing data, and then presenting results. I see engineering more as the sort of the creators or the implementers of whether it's a website or an app or kind of whatever the company is building.
So if you were learning data science from scratch, how would you go about it?
I would go about it the way that I did it myself, which is just pick a problem and try and solve it. So for me, my first job, I was trying to classify web pages, and it was a way for me to get out of a lot of my kind of day-to-day work. And so it became a side project that I was working on, and eventually it led me to Pandas and led me to scikit-learn and some of these other great libraries for data science and analytics, and one thing led to another, and I guess I just kind of got the bug.
Do you have any preference for if a new data scientist should start with Python or R?
No, I think it's really just a matter of preference. I would encourage people to kind of look to their peers. So if you happen to work at a company that has a lot of R users, R would probably be a good choice for you, just because your support network is going to be a lot better. But in terms of whether R or Python are better, I think they both have their merits. They both have their weaknesses. They're pretty similar anyways, so you might as well just go with the one that fits you the best.
What do you think about the Giulia language?
I've been hearing a lot about it for a while, and it's an interesting project, but it just seems like it's not ready for prime time yet. I think it's still going to be another year or two before it's like actually feasible for regular users, hobbyist users to be using it at work.
What are the deficits?
From what I've found, I mean, it's still just evolving. It's still new. There's a lot of tooling that still needs to be built out around it, and the community is just not as big as the R or Python community yet.
Is it easier to teach data science to an engineer or engineering to a data scientist?
Oh, that's a tough one. I don't know if there's a answer one way or the other. I think it just depends upon the individual and whether or not they are interested in some of the more analytical and statistical concepts of data science.
So I want to go through a simple data science problem. There's a talk that you gave about how to build a beer recommender system using Yhat, and I'd like to talk through an abbreviated version of this talk because, and I'll put it in the show notes, the presentation that you gave, but it's a really good, solid example for somebody who has no idea what data science is or what kind of problems you can solve with data science. So this problem, to start with, we have a collection of several beers, and we have user ratings for those beers. So each user gives a simple 1 to 5 star rating of a beer. And we want to be able to measure how similar each beer is to other beers. So then if a user likes one beer, then we can recommend similar beers. And as you said at the beginning of the show, there's plenty of applications to this, such as Amazon. So what are the steps to take to build this recommendation system?
Yeah, so the first thing, and arguably the hardest thing, is that you need a data set to work with. And so the blog post or the talk that you're referencing uses an open source data set from the website beeradvocate.com, and they've been around for a pretty long time, and so they had a collection of about 1 million reviews that we could work with. The next step is to take that data set and come up with a way to condense it down so that it's a little bit easier to manage and a little bit easier to understand. So in this example, what we decided to do was look at how individual users were rating certain beers and then compare those users to other users who rated the same beer. So for example, if I really like Sierra Nevada, I also like maybe Coors Light, we could look at other users who also liked Coors Light and use that as a way to say, well, if those users like Coors Light and Greg likes Coors Light, they might also like Sierra Nevada. So we used what's called a distance matrix to quantify that relationship. And then using that distance matrix, you can, Jeff, like you said, take certain lists of different beers and compute optimal recommendations based off of the distances or the relationships between each one of those beers.
Yeah, so I think the crux of this is like you can turn each beer or each object in a recommendation system into a matrix of numbers, and then you can plot those numbers in Cartesian space, and then you can use cosine similarity or some other similarity formula to gauge, how similar one vector space is to another. Why is cosine similarity so useful?
To be honest, I'm probably not the person to answer that. I'm a much better engineer than I am a data scientist.
That's fine. I've known about cosine similarity for like 4 years and still don't know why you use it over other things.
Yeah, and I think that's actually part of why data science has gotten so much more accessible is that I don't have to know the nuts and bolts of cosine similarity to use it because these third-party libraries, these open source libraries have gotten so good. So I can use, Manhattan distance, cosine similarity, Euclidean distance without having to think twice about how to implement them or trying to guess, in theory, which one would be best. I can just try them all out, see which one seems to work best, and just take it from there.
Cool. So I'd like to close off with some kind of rapid fire questions. What is the biggest engineering problem that Yhat is facing right now?
The biggest thing is we've put in a lot of work to making it extremely easy for us to build software that can run on premise. And so it's extremely challenging to build software that kind of runs not on your own servers just because we don't have control over it. We're not there to babysit it. And that's something that we put a lot of work into over the past 6 to 9 months.
How do you do hiring at Yhat?
We found people from really all over. We've had referrals. We've met people on Twitter, through LinkedIn. But the probably the most important part of our hiring, at least on the technical side, is we'll bring in a candidate for a kind of a hack day where we'll work on them on a whatever project. It could be something that they've been playing around with. It could be an open source project that they're trying to learn more about, and just build something. And we found that that's the best way to get a sense of, well, one, someone's technical ability, but also, and what I think is really important, what it would be like to work with that person. Especially for us, we're only about 10 people, and it's really important that we can work well with everyone else on the team and that everyone gets along and is able to work together effectively.
That's a strikingly different interviewing strategy than the typical boilerplate whiteboard interview.
Yeah, I don't like the whiteboard interviews. I have done them in the past, both on both sides, and I've just never found them to be that great of a way to assess how well I'm going to work with someone.
Yeah, it's kind of a tragic legacy icon of software engineering.
Yeah, to be honest, I don't know how to implement like merge sort or bubble sort or any of those.
Then you're fired.
Yeah, exactly. So, it's just never struck me as like a relevant line of questioning.
Very interesting. Well, Greg Lamp, thanks for coming on to Software Engineering Daily. It's been really fantastic talking to you.
Yeah, thanks, Jeff. Thanks for having me.